Okay, I'm going to make a video over this problem number 29 because we did it in class in the year 2016, maybe after that by the time you see this video, but it was a little trickier than you first expect. Okay, first of all, we got to think about the fact that this is asking us what's the limit as our function is way over here at negative infinity. We're talking about looking at x's that are negative here, and that's a key thing, and it's because of this right here that we have to think about this. It's a key thing. And it's going to play into our problem in a minute, so kind of keep that in mind. Now, if I were to try to evaluate this limit and I plugged in infinity for the x's, I would get infinity over infinity, and that's the indeterminate form, doesn't tell us anything, so it's not helpful. Can't cancel that out and say it's 1, unfortunately. All right, so what we have to do when we have situations like this is go ahead and divide out the largest x or the power of x in our problem. Okay, so we've got 2x plus 1. I'm just going to leave myself a little room to work here. And then we got the square root of x squared minus x. Okay, if I divide by x, remember that if you look at it, the largest power is x, because on the top it's x to the first, and then on the bottom the square root of x squared would be x. Now, if I divide by x, remember that it's a negative x, okay? It's a negative number that I'm dividing by. What I want to do is divide that x out, and normally it wouldn't matter, okay? Normally it wouldn't matter. I can divide everything by x. But down here on the bottom, to divide, a lot of times we just go stick this up under the radical if it's a positive infinity, but here this is getting a little tricky. We're going to divide by x, but I'm going to write it as x squared. Now, the square root of x squared has a positive root of x and a negative root of x. Which one do I want here? Normally, I don't even have to think about this. If I'm approaching positive infinity, we just kind of don't think about it so much. But we're talking about a negative x over here, aren't we? And that's really what I'm doing is I'm dividing out whatever that number or large number is that we're looking for. We don't know what it is, and we're representing it with an unknown. So what I have to do here is say when I take that square root, I want the negative of it, okay? I want the negative root, not the positive root, because I want a negative x, not a positive x. I'm not at the positive end. I'm down there at the negative end. So it's kind of something we have to think about when we're doing our algebra that normally we wouldn't probably even worry so much about. Okay, let's see what we got now. We got the limit as x approaches negative infinity. Now 2x over x, the x's cancel out on top, and I just get 2. And I got plus 1 over x. Now on the top, this is not mattering, because if I plug a negative number in, I'm going to get a negative number out. It's okay. It's not like any stuff's going on. The reason I had to be careful on the bottom, and the reason I had to put that negative out front, was if I took that negative number and I squared it, it would be a positive number, and that's going to affect it here. If you were to actually type this thing in on the calculator and look at it, you would see that there's a limit over here that it approaches. Remember, the limit is the horizontal asymptote. So there's one limit on the positive side, and on the negative side, it's a different limit. So we got to kind of keep that in mind. We can see it if we look at the graph of it, but if we're trying to do it algebraically, we have to adjust with that negative sign out front. Now that I've separated the negative sign out front, so let me do this. Now I'm going to go in and divide. I'm dividing still by x, because the square root of x squared is x. But I'm going to go ahead and combine these under a radical now. When I did this in class, at first I didn't do this, and then we didn't get the right answer. We got the positive answer instead of the negative answer, so I had to kind of go back and think why, and then look at what we should have done differently. Okay, now, this is a negative times all this. Okay, if I go and simplify that a little bit more, I could, if I've got, let me ask you something. If I got 2 over negative 1, isn't that the same thing as negative 2 over 1? So if you look at the key in the answer key, they go ahead and they move the negative up to the top. And I'm just going to go ahead and do that now. I'll just put it up at the top. I've already reduced the top. On the bottom, what I end up with is the square root of x squared over x squared. That simplifies to 1. And then x over x squared becomes 1 over x. Okay? So now I've taken into account the fact that I'm working in the negative numbers, and I can just kind of do the algebra now, keep up with that negative sign. Let's plug the infinity in now. Instead of writing it out, since I'm running out of room, I'm going to say, oh, I'll put the infinity here, and I'll put the infinity here. I'm direct substituting now. That becomes negative 2 plus 1 over infinity approaches 0. And we actually had a theorem that told us that in this section. I'm looking for the page number for it. It's theorem 3.10, page 199. Okay, I don't have room to write it, or I would. So this becomes 0, and on the bottom we've got the square root of 1 minus 1 over infinity also approaches 0. So this becomes negative 2 over the square root of 1 is 1. So our limit is negative 2. We have a horizontal asymptote, in other words, at negative 2 down here. That it means the same thing.